Let's start with the standard equation of a plane. I might have already mentioned what I would call the general equation of a plane. Any linear equation of the form, let's say ax plus by plus cd, or cz, excuse me, equals d, I would maybe call the general form of the plane. Different books have different, they use their own terminology because it doesn't really matter what you call it. It matters that you recognize for constants a, b, c, and d and variables x, y, and z, you recognize the fact that this is a linear equation with 3 variables. How do we know it's linear? All the exponents on the variables are 1, right? Or 0, I suppose. If z was missing, it would still be a plane. So it's a linear equation with 3 variables, and that means in space you've got yourself a plane. So I would call this the general equation of the plane. And then there's also something called the standard equation, which I want to develop for you right now. So you're going to have to use your imagination here because you know my artistic skills are not that great. Imagine a plane in space, which, to give it some illusion of depth, I draw a segment of that plane in space as a parallelogram. So imagine this is a plane in space. And imagine that the points P and Q lie in the plane. And we're going to form, now Q, by the way, is the point X, Y, Z. And P, so Q is any point. X, Y, and Z can vary. And P is a specific point in the plane that you have to be given to find the equation of the plane. So X naught, Y naught, Z naught. Just like P was a specific point on the line, and we called that X naught, Y naught, Z naught. P is a specific point in the plane, and we designate those specific coordinates X naught, Y naught, Z naught. Now, we're going to need a point on the plane to find its equation and a normal vector. What do I mean by a normal vector to a plane? A vector that's perpendicular to the plane. So imagine a normal vector like so. So imagine this is your normal vector. We could call it n. And it forms a right angle with the plane. Okay? And then we're going to imagine the vector PQ in just a second, so I went ahead and drew it in there. Okay, so how can I use a normal vector and a point on the plane, this point P, let me draw that a little bit bigger. How can I use a normal vector and a point on the plane to find the standard form of the equation? Well, let's do this. Let's give the normal vector some coordinates. Let's call the normal vector, let's say the components of the normal vector are A, B, and C when you put it in component form. Need a little more room there. A, B, and C. Okay, so consider the normal vector to the plane A, B, C, and I also want you to consider PQ as a vector. Can you tell me the component form of PQ? Do you remember how you find component form? I can't write this too many times, I don't think. You're going to take the tip minus the tail, right? So what would PQ be? X, first component, good. X minus X naught?
Y minus Y naught, Z minus Z naught.
Z minus Z naught, okay. Good. So now we have a normal vector to the plane, which is also normal or orthogonal to PQ, right? Because PQ, the vector PQ, lies in the plane. So note, N is perpendicular or normal to PQ. Orthogonal really what we use is orthogonal when we're talking two vectors. That means perpendicular. And we use normal when we're talking about a vector perpendicular to a plane. We use the word normal. Why we have so many different words for perpendicular, I don't know. But we do. So because N and PQ are orthogonal, what do we know about their dot product? It's 0. N dotted with PQ is 0. Remember, the dot product is an orthogonal vector detector. And it's the number 0, right? Because the dot product is a scalar. Oh, okay. So can you actually take this dot product for me? So you'd have A times what? Good. A times x minus x naught, and then what would you add that to? B times y minus y naught plus C times z minus z naught. And that has got to equal 0. And so by using that dot product and the fact that N and PQ are orthogonal, we can come up with what we call the standard form of the equation of a plane. Okay, this is your standard form. A, B, and C are the components of the normal vector. X naught, Y naught, Z naught, a point on the plane. Okay? So what did we just discover? You need only two things to find the equation of a plane. You need a normal vector and a point on the plane.